Hello, in this video we are going to determine the end behavior of a function given in factored form, and that is our objective in order to help us graph polynomial functions. So the first step that we have to follow in order to find our end behavior is to determine the leading coefficient. And in this case, you do not see a coefficient out front, so therefore it's an invisible one. However, what we do see is we see a negative value out front, so therefore our leading coefficient is -1. The second step that we have to follow in identifying end behavior is we have to determine the degree power of our function. And in this case, we have 1, 2, and 3 zeros. So therefore, this is going to kind of resemble a cubic function with our end behaviors being different. And the last step is we want to kind of draw a picture. So normally, cubic functions look something like this without this extra squiggle. Over here, they look something like this. However, we do have a negative coefficient, so what happens is we get x-axis reflection. So with this, our cubic function ends up looking like this. So therefore, we can go ahead and we can state our end behavior, which is as x goes to -infinity, f of x goes to +infinity. As x goes to +infinity, f of x goes to -infinity. And you can see these endpoints. Here is where x is going towards -infinity, right? And then it goes up. The graph goes up, your output. And for the other side, here, as our function is going towards +infinity, our graph ends up going down to -infinity. Okay, and thus we have accomplished the problem. We determined the end behavior of a function given in factored form, as seen here.